Right. Good morning, everyone. How are we doing, guys?
Good morning.
Doing good. So let me give you a little bit of background, guys. It's kind of unimportant, but I still want to share with you. I'm not in Valdosta. I'm in Florida, and I will be in Valdosta tomorrow. We'll try to have a regular class. There may be a little bit of noise. There are two other people here, but I hope you will be able to tolerate it. We are recording. So as usual, again, my apologies if there is a little bit of background noise. By the way, can you guys hear me? Can anybody confirm?
Yes.
Awesome. So if you want me to repeat something, just don't hesitate, just tell me. So here's the deal. This is actually 2.5. So the plan is to work on 2.5. 2.5 is a bit challenging. I don't believe we will finish it today. I do it over 2 class periods because it is a difficult chapter. Now, before we get to 2.5, you guys did fine on your exam 3. So if you have any questions about exam questions, do that, do this. Not a bad time to ask. If you have any questions about anything we have done up to 2.4, feel free to ask. I'll pause a little bit to see if you have any questions for me to answer. A little bit of while you are thinking, your exam 3 scores have been updated. And if you go to look at the quizzes, exam 3 is now available as a no credit quiz option. You can take it 10 times. No credit exam 3. I don't know why. What is it? Oh, it's hidden. Let me make it visible to everyone. So you can take it if you want. Again, as before, if you want me to grade it, it won't change your score. I'll be happy to grade it, but you have to email me and tell me that I took exam 3 again. Could you grade it? I'll be happy to grade it. Okay. Any questions from old stuff? Let's see how many are here. We have a small class today. All right, guys, we see only 4 people. Okay, so guys, let's start 2.5. So the class shouldn't be much different really, except for we're in a new place. I have my laptop, my notes and everything. It should be hopefully very similar. There will be a little bit of noise. All right, guys, so it's called transformation of functions. Okay. And we're going to move functions around. We're going to move things around. Okay. Before we do that, I want to tell you what some of these functions will look like. You have seen them in many sections. Okay. We plotted these curves. We talked about slope. We talked about quadratic functions, but I am going to go to Desmos and discuss them a little bit. Okay. And the functions that we will be talking about are right here. You can see on the screen. The domain range are also here. That's going to come in very handy. We discussed domain and range.
We can't see your screen.
Oh, I'm so sorry. Absolutely, you can. Okay, so here's the screen, transformation of functions. We're going to introduce you to some of these. By the way, can you see my screen now, guys?
Yes.
Wonderful. So guys, the first one is very easy. I'm going to go to Desmos. Okay. I'm going to do it in this order. This is going to be the first one. This is going to be the second one, so on and so forth. It's called a constant function. We won't see it much. We'll see some of this. We'll see some of this. We'll see some of this. Now these, let me tell you a little bit, I'll give you a little bit of background. Most of the things, I like this function, this function, and this function the best. So a lot of the problems I'll give you can be done or can be applied to any of these 6 functions, but you're going to see more of this. I'm not saying don't study the rest. Okay. So let's plot the constant function. Okay. A constant function. I'm going to explain to you why the domain is negative infinity to positive infinity, why the why the range is just C and all that, but I'll give you a specific example like 3, 4, 5. So don't worry too much if you can't see it. It's on the first part of 2.5. If you have your book, which you have access to, it's on maybe, I don't have the page number here, but I don't want to go to the book, but it's in 2.5. Okay, so let's plot our constant function. So we're going to talk about this mostly today, okay? And we'll talk a little bit about transformation of functions, but just a little bit, the easy ones will be discussed. So guys, in your book, the constant function is like y is equal to 4. I'm going to take one more. Y is equal to -5. Let me see if I can do this. Okay, so guys, let me see what else I can do. Give me 1 second. Okay, a constant function will always be a straight horizontal line parallel to the x-axis. So if it is y equal to 4, it's going to go through 4. It's a horizontal line, so it will have a slope of 0. Okay, we kind of discussed that. If here it's not that important. If it's -5, it's going to go through -5. And this is -5. You can barely see it because the line goes through it. So let me make it, just to make it more visible, let me make it -6. So y is equal to -6 is going to go through the -6 line. Okay, it's going to be a horizontal line. So what's the domain of this function? Let's forget about this. Let's take a simple example. What's the domain of this function, guys? Remember, domain is defined as follows. You walk on the curve, okay, and you only think about the x coordinates. The x coordinates can be anything, all real number. It could be -5, it could be +5, it could be 0, it could be 10. So the domain will be the set of all the x coordinates you could possibly have. And the answer is -infinity to +infinity. Actually, we should do this kind of a bracket. That's more accurate. That's correct. Give me 1 second. All right. Range. Range is kind of the same thing. Let's do it in green. This time, you walk on the same curve, but you think about, you think about the y coordinate. What is the set of all possible y coordinate? Look, your y coordinate is not going to change. It's a horizontal line. It's always going to be +4. So your range, I'm going to just write range, is just one number, +4. We don't put it in interval notation when you have one number like 4, -5. So the range is 4. Now I'm going to do each graph and talk about range and domain. Okay, it's something we have done, but it's worth reviewing. Now, so it's called the constant function, and that's all you kind of need to know. And the good news is it's an open book exam. You should have access to this document or page, and it's going to come in very handy. Okay, then there is another function called the identity. Identity, if you say it fast, it sounds that way. Identity function. Okay, well, let's go to this one, guys. Go back to this one. Identity function is this function. It's also a very simple function. We have seen it. It's like y is equal to x. And we're going to show you. That's what we got for our domain and range for the previous one. We're going to show you the domain and range is this. And they're talking about increasing. We can talk about it. We're not going to worry about it too much. It is an odd function, all those things. But they're telling us a lot, but we don't need everything. So I'm going to draw y is equal to x. I can write f of x equal to x. Doesn't matter. And again, guys, you have to tell me. Can you repeat that again? What did you say? Okay, so it's basically y is equal to x is called the identity, I-D-E-N-T-I-T-Y, identity function. It's basically a line that goes through the origin. It's a slant line. Okay. And if you do your rise over run, you're going to see it has a slope of 1. We don't need it. All we care about is, we care about two things at this point, the domain and the range. So ask yourself, if you're walking on this curve, okay, like so, just on the green line, and now imagine all the possible x coordinates. The x coordinates could be anywhere on the x-axis. If you're here, it'll be here. If you're way in the top right corner, it's going to be way on the right, and the x coordinates can be here, can be here. So your domain, I'm going to just write D, is going to be negative infinity to positive infinity. And your range is the same thing. You're walking on the same curve. You're trying to ask yourself, what could be the set of all possible y values? I'm going to change the color. I really don't need to because I will be on the same curve, but might as well. I'm going to say the range is, let's take blue. I'm going to walk on this curve. I'm going to be pretending I'm an ant. I'm walking on the curve. What could be my y coordinates? Well, y coordinate could be this, could be this, could be 0. If I'm here, it'll be something like this. The y set of all possible y coordinates, if I am on the curve, is also negative infinity to positive infinity. I'm going to call this the range. Okay. Again, it's an increasing function. Your table says that. I don't think we're going to use it that much in this section, and you should understand what it means. So that's how we find the domain and the range of the identity function. Let's write down the identity word, the word identity here. So this is called the identity. There's only one. Let's pause there a little bit to see what's going on, guys. It always looks like y is equal to x or f of x equal to x. Doesn't matter. Whichever one works for you. We have seen both. We should know both. So you're going to see the functions we work on will increasingly get difficult, not overly difficult, but a little more challenging. Again, you can always say, can you go back, explain that again? How did you get negative into positive infinity? All those things are totally fine. So what I am thinking, guys, as I was thinking about this, I'm going to get rid of this, the marks. Okay, so we did this. We did this. I'm going to show you, I'm going to talk about this absolute value function and this function today. That's all I'm going to show you today. Okay, and then we're going to talk about real transformation. All right, then next class tomorrow, which we will meet from our house, from my house in Valdosta, I will talk about these three. And then we're going to continue discussing transformations. Okay, so let's do the next two. This is called the absolute value function. Absolute value, now you can read. And this is called the quadratic function. We have seen both. All right, let's graph the absolute value function and talk about its domain and range. Again, this is Desmos. You can do absolute value from the bottom right corner. I know some of you probably use this. Let's see where it is. Right here, X. It looks like a V. V, the letter V, it looks like the letter V to me. And let's talk a little bit about the domain and range. Well, the domain, if I walk on this curve, the domain is going to be the set of all X coordinates. So the domain will be negative infinity to positive infinity. I'm sorry. Let's go back. All right. The range. Now range is a little tricky, guys. I'm going to use a different color. So the range, let's use something that stands out. Let's use pink. So I am gonna do the same thing. I'm gonna walk on the curve. I'm asking myself, what could be my possible y coordinate? Now, if you see, I will always be above the x-axis. My y coordinate will never be negative. They can be positive. They will always be positive, but they can also be zero. So if I am an ant walking on this curve, going all the way to the right, all the way to the left, my y coordinate, no matter where I am, my y coordinate can be zero or positive. So how do I write that? I'm not going to say negative infinity to positive infinity. That would be incorrect. I'm going to put a square bracket here. I'm going to tell you why. 0 to positive infinity. What does that mean? That means my y coordinate, set of y coordinates could be anything starting with 0, including 0, and then it can go up. It could be 1, 2, 3, 4, 5, 6, goes on and on and on and on. One tiny thing, then I'm going to pause here to take some of your questions. Again, this is not something we need for this section, but we have discussed it. It's a good place where we can review it. From this point, the curve is decreasing. We always move from left to right, and the curve is increasing. If somebody asks you, where is it decreasing? You would say here, negative infinity to 0. Where is it increasing? 0 to positive infinity. They're not going to ask us here, but it's something that's worth noting. So this is a curve that decreases above the negative part of x-axis, then increases. I'm going to pause it just a little bit. Okay, guys? Wonderful, guys. Any questions? Don't hesitate. Don't be shy. So let me do one more curve. All right. Let me do one more curve. And this is the one we'll be working on. So we learned about absolute value function, the quadratic function. Quadratic function is also very simple. I know you probably can't see it so well. It's y is equal to x squared. Okay, right here. Now I'm going to graph it on decimals and you're going to see it a lot better. And that's very easy to do. You can just say x caret squared. All right, so this is what it looks like. It's basically a U-shaped curve, parabola. It's called a parabola. It's not that important. We're just going to call it a quadratic function. That's what we're going to call it. Slash quadratic function. That's the word we'll probably use, but it is a parabola. It's called a parabola. All right. So guys, I don't need the name that much. I'm going to get rid of this. All right. So guys, again, I'm going to talk about domain and range. The function is f of x is x squared. It goes like this. If you want to talk about increasing and decreasing, it's kind of like in that sense. It's kind of like the absolute value function. It's decreasing on the left of the y-axis. It's increasing on the right of the y-axis. What's the domain, guys? The domain is if you're walking on the curve, what is the set of all possible x values? If you're way on the top on the left, beyond the screen, your x values will be, it goes on and on forever. Okay, you have to get that. It goes on and on. All right. So you're gonna say your x coordinate or the set of x coordinates could be anything, negative infinity to positive infinity. And let me write it down nicely. For domain is negative infinity to positive infinity. Range is just like absolute value. It includes 0. It cannot be negative. It could be anything but any negative numbers. And I'm going to explain it to you on the curve. I'm going to write it like this. That's my range. Because no matter where I am, my y coordinate, remember, range is about the y coordinate. Range is always going to be positive, including 0. Okay, 0 is an exception, but it will never be negative. If you're on this green curve, no matter where you are, your y coordinate will always be either 0 or positive, and that's why it's the range. 0 through infinity. Do we include 0? The answer is yes, because this curve goes through the point 0 or the origin, because when x is 0, f of x is 0. So this is on the curve. Origin is a part of the curve. That's why you want to put square brackets. So these questions to me are easy questions, and you will see some of them on the final. Some of them, I would consider them some of those easy questions. I do throw in a couple of easy questions. So I'm going to pause here just a little bit. Once again, a little bit of recap. We talked about, and you can always interrupt and say, could you explain that again? I'm not getting rid of the graph. I'm just going to tell you what we have done so far. And I think we are ready to discuss transformation and go to the main part. We have talked about this. 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 Now, not a huge fan of this curve. Not a huge fan. This is a good enough curve. I will actually discuss all of them. You should know all of them. But let's talk about transformations. What does it mean? So I'm gonna actually, I didn't pause at all. So let me pause it a little bit to see if people have any questions either about this slide or about this slide or any other functions that we have talked about. They're all here. You have to tell me, go to the other page. This page, I call it the Polypad page. Polypad, I don't know how well you can see on top. Give you a couple of minutes, a little bit of pausing. All right, guys. So we are going to talk about transformations of functions, okay? And I'm going to use the word your text uses. Every text uses words that are slightly different. I'm going to use, there are many transformations. We're going to do the easiest one first. Okay, we're going to talk about vertical shifts. Vertical means going up and down. Okay, horizontal means going left and right, from left to right or right to left, doesn't matter. Vertical is up and down, down, up, doesn't matter. So how do we take a curve, move it up and down? How do we do that? Now, since this function happens to be here, f of x is equal to x squared, the quadratic function. So what happens if I make a g of x equal to, take my same quadratic function, but stick a +3. Now, what happened? Again, just to let you know, this little blue color is the blue curve. The green color is the green curve. I have two curves. The green curve is my original curve. It's the quadratic function. So what did I do? Well, the next one is quadratic too, but green one is, some people use the word parent function, the main function. I'm just going to say the main function. Let's move it like this. Show you what is going on. What is the connection between the green function, which is this, and the blue purple function, whatever you want to call it. It's probably purple, x squared plus 3. What language would you use? What's happening, guys? It's called a vertical shift. It's really same as taking the green curve, pushing it 3 units up. So this is called a vertical shift. It doesn't matter what function you start with. If you add 3, the whole curve is pushed 3 units up. I'm going to give you one more example, okay? I'm not going to hide it. I am going to hide this, but I'm not going to erase them. Let's consider, let's call f of x absolute value of x. my v function, okay? Right here, like I thought it would be. And now let's do g of x, my transformed function, the same absolute value function, but added. What happened, guys? Again, the black function is the original absolute value function. F of x is absolute value of x, and g of x is the previous function, but a 4 added. What do you see, guys? Anybody wants to describe it? Unmute herself or himself. Anybody? What is being described, or what's visible? What's going on, guys? This guy is this function. What's the relationship between the red and the black function, guys? Isn't it like a vertical shift? Go ahead, I'm listening.
Is it their x-axis is the relation that the two have?
Yeah, what's the relationship? What would you do to the black function to get the red function? How would you describe it in
You
English?
just change the y-axis to increase by 4.
Right. So exactly. So it's called the vertical shift. Okay. Vertical shift. Why vertical shift? Because it just seems like I'm taking the original function and putting it up vertically, pushing it up vertically. How many units? 4. So I'm going to show you something that looks very interesting to me. So that's why I like Desmos. Okay. Let me show you this. I'm going to call it A. And A is a slider. A starts with, take a look, the red function, A. This A, let me see what else I can do. I'm going to make it a whole number, okay? Just for the sake of simplicity. Make it negative 0 to, excuse me, guys, 5. And step on. You don't have to know it, but I'll show you. So guys, this red function g of x is the same absolute value function plus a. What is a? I can change it. A is 2. A is 3. It's going up 3 units. Take a look at the red function. The black one is anchored. The black one is my main function, absolute value function. I know everything about it. What's the red function? It's basically the black function going up. 3 units, 4 units. When A is 4, it's up 4 units. When A is 5, it's up 5 units. I only selected up to 5. I can select 10. I don't think that's a problem. So do you see? It's if A is 3, it's going to take push the black curve 3 units up. If A is 4, it's going to push the black curve 4 units up. It's called a vertical shift. Does that make any sense, guys? Yes, no?
Yes.
Awesome. So guys, what happens? I'm not going to do A, if you don't mind. A will work. I'm going to do -3. So take a look what happens, guys. Again, the black curve is my parent curve, main curve. The blue one, if I say -3, it goes down 3 units. It's a vertical shift, but what kind of a vertical shift? 3 units down. What happens if I do -4? It's 4 units down. Okay, what happens if I do -5? It's going to do the same thing with the quadratic function. So let's take our example, hide the absolute value functions. Let's go back to our x square. That's our quadratic function. The blue one was x squared plus 3. Let's make it -3. And it does the same thing. Look at the blue one. It goes down 3 units. Well, how about -4? Well, it goes down 4 units. How about -5? It goes down 5 units. So here's the summary. Okay, what do we mean by vertical shift? This is what we mean. If you add C plus C, it's going to go C units up. If you subtract -C, whatever your function is, they're calling it f of x. It could be anything. It could be absolute value of x. It could be quadratic. It doesn't matter. It's going to go down by C units. And this is what we mean by vertical shift. I'm going to pause there a little bit. It's very fancy here. You know, we gave examples with 3, 4, 5. They're calling it C, but it's the same thing. Okay, we said -3, -4, -5, +3, +4, +5. They're saying plus C minus C. They're being a little more professional and, you know, textbook-like, but it's the same thing. Desmos is a great tool to observe it. I'm pausing here a little bit, guys, okay? To give you a little bit of time to absorb. I have all my notes up here. You can say Desmos, Polypad. Okay, guys, you can almost guess what's coming up. This is called horizontal shift, and it's a little tricky. Okay, so be a little patient. What is a horizontal shift? Well, I'm not going to show you with C yet because C is a little complicated. I'm going to go back to my Desmos. Okay, now this one, as I said, this one is a little tricky. Now, instead of X, let me make it a little bigger. Instead of X, I don't need this. Okay, instead of this original function is not going to change. It's going to be X squared. Instead of X, I'm going to write X minus 2. What happens, guys? I'm asking you, what happens? Don't ignore this, okay? Ignore the absolute value function. We're going to use it, but we're not graphing it. This green one is the original function. We know what it looks like. We know what its domain is. We know what its range is. We have discussed it. We know where it's decreasing, where it's increasing, all those things. But what is happening? Can somebody describe in English, guys, what's happening? What's the relationship between the green one and the purple one? What's going on? How would you describe the movement?
It's through the x-axis.
Exactly. So it's a horizontal. When you say x-axis, we're going left and right. So it's called a horizontal shift. Okay. And exactly by 2 units. Now, as I said, it's a little tricky. So guys, I am going to make it A. Okay. You will be able to see the things a lot better. I'm going to take my A. I'm going to start with 0. And go up to 10. Not that it's that important. You won't be using it in your, when you take the exam, you won't be using it. So bear with me, guys. This little a right now is 1. This little a is 0. And I'm going to get rid of this. It's just a distraction right now. So guys, what happens when a moves from 0 to 1 to 2 to 3? Look, a is 1. It's 1 unit. When you have -1, it's called horizontal shift to the right. Again, the tricky part is -1 goes to the right. -2 is 2. And in my formula, there is a minus here, right? And it's 2 units to the right. And I don't know how well you can see, but it is 2 units. This is 1, this is 2, this is 3, this is 4, this is 5. I'm going to show you 3 units to the right, 4 units to the right, 5 units, and you have to keep it straight. Students make this mistake all the time when they see minus. And let me do one more. Well, we're going to show you. When they see minus, they think it will go left. It doesn't. Actually, the -1 goes to the right. And you can almost imagine that plus a will make it go to the left. Let's show you one more. What happens to 6? It's 6 units to the right. Okay, right here. All right, what happens when I replace a with 7? It's 7 units to the right, and you have to say it, okay? You have to say it in English. There will be questions like, here is f of x, here is g of x, describe the transformation. And you can graph it, you can use Desmos, and you have to say f of x and g of x, how are they related? That could be a question. We're going to do some problems from your book. You will say, well, g of x is f of x moved 5 units to the right, or 5 units to the left, or 4 units up, 4 units down. You have to tell me how far it goes and in what directions. You have to tell me both. If you just tell me one thing, just say horizontal shift, doesn't tell me if it's going to the left or to the right. All right, so let me give you one more example here. This time I'm gonna do replace x with +2. Replace x. I'm going to come back to a later. Okay, I don't need it now. Instead of x, this is my x. Instead of x, excuse me, instead of x, I'm replacing it with x + 2. What happens? Well, it's 2 units to the left. Remember I said plus 2 means left. And you can almost guess 3 will be 3 units to the left. Plus 4 will be 4 units to the left. Now let's do it with A. A is more visual and more interesting. And I'm going to make it, sorry, I'm going to make it 0 and -10. -10 will work. It's a little tricky, not really that bad. We'll see how that goes. Okay, what did I do? So okay. G of x is minus, okay. So this will go from 0 through plus 10. Sorry, I'm going to explain to you. Give me 1 second. So A is 1, A is 2. When this A is plus 2, what do you get? 2 units to the, it moves 2 units to the left. Plus 3, 3 units to the left. Plus 4, 4 units to the left. Plus 5, 5 units to the left. Plus 6, so on and so forth. Again, if you replace x with x plus 3, x plus 4, x plus 5, whatever that number follows after the plus sign, it will go to the left. I have a little slide that describes all the transformations on 1 page. Your book has one too. I don't like the one your book has. It's adequate, not perfect, but I'll be happy to upload it, okay? Before we wrap up in our notes folder, so you'll have a copy. So far, guys, we have really talked about vertical shift going up and down and horizontal shift going left and right. Okay, so we discussed those two, how they transform the functions. Okay, guys, this is going to kick me out anytime. Okay, let's get out of here and come back really quickly. We're not finished. I'll see you guys really soon.